First thing I'd like to start out with is ask you a question on a traditional filter that you spin on your vehicle, your oil filter. When is it most efficient?
Right at the end.
Excuse me?
Right at the end.
That's good.
He's heard the question before.
Most people
Just before failure.
most people believe a new filter is most efficient when you spin it on. And actually what happens, it starts out at a percentage, and if it's 20 micron, everything below 20 micron is going through that filter. So it doesn't start doing anything until it starts catching bigger particles. And then it starts filtering the smaller ones. So it'll start plugging off, and right before it plugs off, it's most efficient, and then it plugs. So you got a real tiny window for efficiency in the old technology filter that everybody's used to. So I got a call about a year ago, a little over a year ago, probably in June, July 2016, a cold business call from David and Roger to come down, and they done a presentation on the magnetic filters, and about 15 minutes into it I was sold. I was bought into them. But my first challenge was my facility manager. Is he going to buy into them? Well, he did. So that kind of got us off the ground and running, but they didn't really want to purchase anything expensive. They wanted a proof of concept. That's what they wanted. So one area that we looked at, we had 2 refrigeration units. You got 6 compressors on each one. You got 6 low stages, 6 high stages. This is the money we spent in 2016. You can see we spent $1.5 million on rebuilds, their shaft seal repair, oil filters, oil pumps, scaffolding, insulation, crane rental. They don't count labor. That doesn't count product that we have to flare off every time we shut one of these units down. I mean, this is just the big hit items. So when our big boss come out, he wanted to know if there was any area where we could decrease our spending. He seen this number and he goes, "What's going on here?" And I told him after listening to Roger's presentation, I believe I could cut this number pretty drastically. So he was interested in it. So my boss wanted to put one out on the docks. Well, this is the one that I wanted to put in. It's on a refrigeration system. There's your coalescer. It's a closed oil loop system. Oil comes out of here, goes through a witch's hat. Roger's filter wasn't here yet. Comes through your oil pump, goes to a 10 micron filter, back to our compressors, and back to the scrubber. Our filters we were changing, we kept record of them. There's a picture of where we pulled it after one ship. And when we pulled this out, we thought we would see, when we cleaned it, we'd have a pile of particles down here, but we actually took a rag and wiped them, and all this absorbed into the rag. That's how fine it was. So we sent it off, had it analyzed, but our filtration system couldn't catch this. It come back below 10 micron. It's 2 to 3 microns, what it is. So this wasn't designed for the flow that we had, so it's not as efficient as it should be. But we had a spool piece that I could take out real easy. Roger designed something that would fit in there and put the magnets in there that would work best we could. And it was a proof of concept is what it was. And I just got, I think Tuesday, delivered 5 more of them for the rest of the skids. So we're going to cut down on our filter changes. Our seals on that compressors, we've seen up to 70 thousandths buildup on the seal face from this trash we're catching here.
What's the throughput on that filter when you're, like I said before you clean? What's your throughput about?
How much flow we get in here? It's about, I'd be afraid to say because I don't want to give you a bad number. But one of the funny things was to me is that before we put this filter in, we got this witch's hat here. I got a $65,000 oil pump, and this is a rock catcher. So one of my questions was, why don't we take this 10 micron filter y'all got and put it before the oil pump? You know what their answer was? We can't. It'll plug off, we'll starve the pump, tear it up. So, me and Roger battled about where we was going to put it. He actually wanted to put it past the filters to prove what we wasn't catching. I understood that, but I wanted to put it in front of everything so I protect my oil pump, protect the filters, and the compressors. So that's where we put it. I won. Here's the sample that we sent off, and one of the biggest, I think it's going to show iron, which is pipe rouge. One of the, I think sodium's in there somewhere, and we kind of wondered where the sodium was coming from. We're loading low ethane propane. In our other facility, they store that propane in a salt dome. And that salt's getting entrained in the product, and we're seeing it at our facility. So it was amazing that there it is, silicone right there. No. It's amazing what we're catching, and then we can analyze what's going on in the compressor, you know, the parts we're losing. Iron's 57%. 57.
You know what I really find hard to believe is that you've got silica, and silica never ever you can't ever capture it. Eh? That's amazing to me. Yeah.
That's 28% of it right there.
Yeah. When I had this one and the other one on order, I bought a small scrubber to filter my new oil that I was putting in my oil bearings and stuff. But I never did use it for that. I started using it for a test unit. I'd go side stream off something. I go, my gosh, look what we're catching here. Get something on order. You know, and it's amazing what we're catching in different processes. Here's the one out on the dock. This is a ship we got there. This is the loading arm, 16-inch loading arm. And we've got, what we had is a strainer basket in here. So when this strainer basket plugged off, we'd have shut down loading, flare the arm down, get the LEL below 10% so we could open this up, do a lockout. This took 6 to 8 hours to get all this done. It'd take us about an hour and a half to clean this and get it back. So it took about 8 hours to do it. We paid Demmurage on these ships $35,000 a day. So if you're down 8 hours, it's pretty costly. And we were doing this at least every other ship, sometimes every ship. So this is where my boss wanted to put it because of the significant savings to do a proof of concept. We put this in 2016, September 24th. And today we have not shut down during loading to clean that since we put magnetic filtration in there. We've chosen to clean it in between ships. Now we did shut down last Friday. Operators was thinking that it was plugged through differential readings. We opened it up, the rods were pretty clean, the screen had a little bit on it, but it was water that was freezing up, restricting flow. It wasn't metals. So today we hadn't had any shutdown.
Do you have a number of the amount of ships you've ran through without a stoppage?
Well, you can figure one ship a week because it's 4 to 5 days to load a ship. I mean, that'd be a minimum number. But if you have Demmurage on this ship, it's supposed to be out in 4 days. The 5th day, the next ship's supposed to load. It don't start till a day later. Then you got demurrage on the ones fixing to come in. So it dominoes. If you got 3 ships sitting out there, you just hit 3 ships with demurrage.
What does that cost
$35,000 a day
per ship?
per ship. And this again wasn't designed. We're flowing 10,000 barrels an hour through the 16-inch line. So the magnetic filtration here should be a lot larger to catch what we need to catch. But it was a proof of concept. So what we're looking at doing, and this is at the tail end of our facility. This stuff is coming in at the front of our plant. So that's where we need to install the proper filter. And it'll be a 16-inch with like 32 rods like that big one y'all seen.
74 inches long.
It'll be big. And what I'm going to do is we have inlet filters with 10 micron sock filters at the front. They're huge. They're Dollinger filters, you know, like this. They go through them. They go through 4 of them. Then they go through the dehydrators. Then they go through the outlet filters. So we got 2 filtration systems set up to catch that stuff. And we're seeing it all through our facility, plumb out to the end of the dock because it can't catch it.
What's the cost of the replacement filter?
It's high. But what's even higher is the disposal because there's norm in it. So we have to mask up. You know, it's you got to treat it pretty careful to deal with it. So if we install one of these at the inlet, I want to install a filter, then I want to bypass around it. There's your valve. So when I do have to clean it, I just bypass it. It goes through my traditional filtration. It may take me all day long, as big as it is to clean it. Then I go right back in it and turn through it. And where I'm really pushing is the pipeline people to buy these filtrations. So when we have 26 miles from Mont Belvieu facility to our facility. If they produce 100% clean product in the line where there's nothing in it at all, I've got 26 miles of pipe rouge coming at me every day, all day long. So, pipe rouge, black powder coming at me every day. And that's what what we're seeing here is. This is what it looked at after one ship, and we redesigned this. This got 4 magnets in it, now we got 7. And we redesigned how they go in there and everything. It works a lot better, but this is on a butane ship where the product is ambient. There's a picture in one of the magazines that shows the LEP ship, and that's minus 42 degrees Fahrenheit. So when we pull them magnetic filters out of there, it's frozen. Everything's froze. So we got to take it back to shore and thaw them out with water and then clean them up and put them back. They're fixing to pull it. There's same thing out on the dock. Iron is the big 79%. Iron's the biggest thing. That's coming down the pipeline to me every day.
So Richie, what would your estimation on savings from just the merge alone?
Well, 35,000 divided by 8, I mean, that's a third of that. You know, $13,000, $12,000 per ship per week. That's what we're saving probably. Just on demurrage, we're saving that. Not counting flaring product, you know, the downtime and all that. Yeah, and that's a $15,000 investment, so it's kind of a no-brainer. You know, even though it's not designed for the rate that we have, it's been efficient enough to where we're not shutting down and cleaning. So we went from corrective maintenance basically to predictive maintenance. We're working on it when we want to, not when it's not telling us when we're going to work on it. Here's another application right here. This is where you get into the refrigeration unit. This is a reclaimer pot, and all the oil that comes off the high pressure flash, low pressure flash, all that drains into here. They take this oil with a pump down this 2-inch and they pump it straight into the suction of my low stage compressor. And the reason they don't pump it back into that coalescer is they don't have the pressure to get back into the system. So they found a place, low pressure, they could pump it back into. So I thought, here's my test unit that I bought to test, to filter new oil. I thought, man, I'm going to test this. This is crazy. That's after 10 minutes. There's 30 minutes, and there's 1 hour. And that's pumping straight into my low stage compressor. And the low stage compressor fails probably 90% of the time. It's, the people that design it come under the assumption that everything's clean and it's going to stay clean. They assume your oil's clean, your tanks are clean, the pipeline's clean, and that is so far from truth, it's unreal. So I had a guy with our company from Oklahoma down that's real big on oil analysis when I done this. And he didn't believe it. He just couldn't believe it. And this stuff here, when you wipe it off, it absorbs into the rag. It's finer than gunpowder. I mean, it's almost solution.
I describe it as wiping the grit off of 500 sandpaper. That's what it feels like.
Yeah. Here's another system I got it in. This is an oil cooler where we got water running by our oil tubes, transfer heat. And these tube sheets where our water goes through is plugging off bad. And we try rotting them out, but if you leave any calcium left on that tube wall, you're losing efficiency. So I thought, I wonder what we'd catch with one of these filters. And what we would catch. There's after 6 days. City water.
So this is just cooling water or heating water?
It's cooling water. What happens, and this is another bad design, they've got a cooling tower that's 15 foot up off the ground. Got these big fans here, and they got a sump in here about 18 inches deep. They pull the water off the bottom of that sump to a pump that goes through these oil coolers. Very bad setup. You got all the dirt roads around there. You got all that dust in there. Pulling them fans are pulling all that in there and dumping out, and we're pumping trash through that. Bad deal. So we're now looking at a closed system with glycol and get away from that water. What we're looking at doing. But we have yet to open these coolers up to see what we're doing there. We'll probably do, we got a turnaround coming the end of this year when we'll open these tubes up and see what we got.
It wouldn't hurt to look at what your velocity is on your water supply to there, because what you're getting in there is magnetite.
Yeah.
And so your coolers, the metal from your coolers, like all that, is ended up in your cooling pond. It's because you're spalding away all the steel in your system.
We also found on our return line that goes back, 2-inch line had a hole about 1/2 inch because the water slows down so much through them. It just calcium just keeps building. So now we've got a problem, but to me, the problem was bad engineering. They had a water source here, and we'll just pull off that and get it. They didn't research what's going to happen, what the water looked like. We're pretty good at doing that. This is on a hydraulic crane unit. All my docks have hydraulic cranes on them. If I lose that crane, I lose that dock. I can't. We handle these big hoses, and if I can't grab that hose, put it on a barge, that dock's dead. I can't do anything. So they had traditional filter here, and it was pointed downward, 40 micron. So I thought that was kind of crazy. So we put a filter on here, and it's the return line, which is the dirtiest oil. Y'all know that's the dirtiest oil. But if you notice here, this reservoir, carbon steel. That is a very bad problem right there. So what I need to do now is put me a filter, magnetic filter, between my reservoir and my pump. So I'll protect my pump and protect the seals in that crane. So it's been a slow process to get these implemented because my boss is busy. You know, it's hard to set him down, get in front of him and get things approved. But the regional manager's on board now. I've been going out and doing presentations to other facilities. Roger and David come over to Mont Bellevue, that big facility we got, and they did a presentation. Everybody's been talking about warranty, and the guy, Roger told him they'd been in business 16 years, been out in the field 16 years. The guy asked him, he said, "What's your warranty on your magnetic filters?" Roger said, "Well, right now it's 16 years. This time next year it'll be 17. Guy didn't have anything to say. You mean you hadn't had anything fail? Not yet. So my company is starting to get the message, but I really don't think I have enough data built up. But we're getting there. To me, this is fascinating. This is the kind of stuff I live for at my job. Something new. Being in the maintenance side, I get tired just fixing stuff. You know, especially when you know it's going to fail 3 months down the road. What are we doing here, you know?
Well, your proof is in your own pudding there, eh?
Yeah, we're going to get there. It's slow, but I look for it within the next year. It just take off. Roger was down. We went to our downtown office and had a meeting, and we had two guys show up. One over e-procurement and one over our MSA stuff. And I'm thinking, this is not the right guys to be in here. So they're doing this presentation, and about halfway through it, an engineer walks in, and he's over a project in North Dakota, and they're having real bad filtration problems. So he got with Roger, give him the data on what he needs. Have y'all shipped anything out to him yet?
Nope, it's in the works.
So slowly, if we get it out to other facilities, you know, by word of mouth, I think it'll take off. Within the next 2 or 3 years, it ought to be implemented in everything we do. Another problem I have is like on new projects. I know they're not going to approve these big filters. I know they're not going to. Not right now. They hadn't bought into them. But at least put the valving in so I can hook up to them when they do approve them. Because to go, after you built it, to go back in there and decommission all that stuff, flare it down, that is so expensive. Somebody said 40 times earlier in the speech, about 40 times greater the cost. So they're going to have to go through some growing pains seeing some of this stuff, before they buy into it. But a year after we built that refrigeration unit, we were having so many failures. We'd built one, and was building the second one, and our compressors were failing so fast we couldn't get one repaired and get it back. So we were robbing them off the one we were building and putting them in. We have just juggled in things from spot to spot trying to keep running. It's crazy. And a year after we was having all them problems, we had all these gurus come in from our company doing RCFA. First thing they looked at was filtration, 10 micron. Can we go to 5? No, let's look somewhere else. Because with traditional filters, that's as good as you can get. I could put a 5 micron filter in there, but my filter cost is going to double or triple, and I'm going to be down more. I'm not going to stay running.
Have your reliability engineers been engaged in that, in this conversation?
Well, we don't have an engineer at our facility, so it's tough to get in front of an engineer We did get in front of one downtown. So that's going to be probably one of our next steps to make this thing move forward, is get in front of the right people in the main office. And when you get enough data where you can prove the savings, then I think they'll probably react on it a little quicker. But right now, they still have a mentality that the filter you screw on your cars is most efficient right then. I mean, that's what they think. So, and without a cold business call, I never would have found this stuff. So I encourage that for everybody that has salesmen come by, because technology will pass you up in a heartbeat. If you've been doing something for 5 years, 10 years, challenge it. I guarantee there's something out there better. And the guy you're buying it from ain't gonna tell you. Because my filter guy, his money's fixing to go down.
This is your filter guy.
That's my new filter guy. My boss made a funny comment when he seen the price of this new one we're going to put in. He goes, "My gosh," said, "Robert's going to be down on the beach drinking pina coladas on us." And I said, "That's fine, David. We got 6 of them doing it now on the system we got." Yeah.
Richie, because of the cost, you say that makes it difficult to implement our filtration systems?
Do what?
The cost of our filters that you're discussing right now, where you're saying that they're expensive, but they're effective.
Yeah, but what's happened with that, with the old filtration system, everybody's got money put in their budget for the filtration system they got. They've got it approved. They got it for the filters. They got it for the failures. They've got it all budgeted. And they think that's the best they can do.
What do you think is the solution to that then?
To get past that?
What would make it easier for you to pass our filtration taking over?
I got to get enough data in front of them to justify the money, because they'll AFE a lot of this stuff, because it'll be a big item. So
Taking zero downtime on filling ships would be,
that's a big one.
yeah.
That's a big one. That one on the refrigeration unit, $2.3 million a year. That's going to be huge.
Yeah, just to run a number, you were asking about saving on Demmurage. I mean, if you just throw down a number on there, I mean, would it be fair to say maybe you save 8 hours once a week on that? Not having to fool those.
So I do it 8 hours every 2 weeks.
Okay. Well, at that's $150,000 in 6 months. $300,000 in a year, just right there.
So I just barely get paid for that $15 a night.
That's right.
So you're saying your cooling tower is part of your issue. Have you been cleaning like the glycol and the water from the cooling
Well,
system?
it's all water.
It's all water.
And we clean it probably once a year. We have to shut down, go in there and drop the drains.
Yeah, I understand like one of the problems with cooling towers is they collect everything, birds,
Yep.
feathers,
Pigeons.
tumbleweeds, you name it. And so, you know, how does that get filtered out as your system's running, or is it just not yearly cleanup that you get that?
We usually shut down once a year, because another thing that messes with us, if we don't have a ship or barge out there, we're not running, basically. So when there's a ship out there, you're not going to shut down and do routine maintenance. You're going to run it till it fails if there's a ship out there. So you have to pick your windows when you can work on this stuff. And next week I may have a 3-day window. We get geared up for it. The morning we show up that morning to do it, guess what? They got a ship coming in. And it just pushes it out and pushes it out. It's crazy. It's a tough place to work on for preventive maintenance. It's very tough. I don't really think our people understood how much problem the black powder was causing us till we put these magnetic filters in. I just don't think they had the mentality of knowing it's got past our inlet filters. When we pull them inlet filters, they're blowed up. They're terrible. Yeah, I know we're catching stuff, but we hadn't pulled the ends of them off so we could inspect the tube sheet to see what's going on.